a couple of days ago, I guess 2-3 days ago, Angular published a RFC preview. So this talk here about signals is the RFC preview version of something that will land in the next versions in Angular and is a tiny clear milestone on a very long roadmap. I will quickly check the time so that I'm in time, and then I can go on. So this RFC preview included a proposal for a new reactive primitive that should land in Angular that is smaller, a little bit less learning curve than RxJS, and should basically be the default reactive primitive in Angular in the future, at least if this RFC proposal survives and really is a success. And today's talk is about that proposal, what the proposal is about, what signals are. It's a little bit of a new animal for us in Angular. We are used to have our reactivity with a library that is called RxJS. This library is, I would say, favorite for having a very splitted community, ones that really love them and ones that don't really love them or that have like problems to use it. And signals should basically, at least this is as far as I understand it, be a more smooth, easier access to reactivity in a framework. Also, the bundle size is quite small, at least from this sketch here, and the whole talk is around this release. So on Twitter and on GitHub, and you can click this link here, or you can type it in your phone, bit.ly/ngwatch this space. This is the title of an RFC preview that I will quickly open. And this got published on the 15th, and it is about a reactive primitive, some promises, some ideas, just some sketches that they are able to present us this new idea. They also mention why they ship a little bit of code before they open up the RFC, and they say this should help the community to get some first experiments and be able to have a better discussion in the real RFC. So this is an RFC proposal. Gives us a couple of cool opportunities or options. And this is brand new, and before I start with the brand new stuff, I want to quickly introduce myself. My name is Michael Latki. Latki is very hard to pronounce, spell right, even for me. Just kidding. So you can stick with Mikey. What I do is I run Push-Based as a CEO, and we are a company focusing on Angular and other topics like performance and architecture in the whole web platform. We do that on a pretty good level. We serve consulting and workshops, and also we can join you as a mid-sized to big team in your development in your company and really see that we can get a little bit of improvements into all your infrastructure that you run. Okay. Next, I will go into what this new built-in reactive should unlock. So, what is their claim? The claim, they say that now with this smaller, easier new reactive primitive, we have agreed to agree on a unified data flow model, top to bottom, change detection, and so on. They claim that, or they say, it should unlock a new way of declarative derivation of state. They say they will help us with this fine-grained thing to give us very small, isolated updates to the UI. So instead of re-rendering the whole application, which we do now, we would be able to get on maybe also on binding level updates to the view. They also promise interoperability with other asynchronous libraries, and they also say this is a first milestone after the standalone story to get fully zoneless applications without any other third-party library like RX Angular. And they also said they want to simplify lifecycle hooks and so on, so maybe we will get some new renewals in those lifecycle hooks and maybe also input bindings too. Let's see. What can you do, or what are like the attributes of this new version of, or let's say of Angular's version of signals? What are they proud of? They listed a couple of aspects in their preview RC, and I just tried to highlight the ones that I really like the most. For example, lazy evaluation at the top of my list is a really cool thing. So you can, in the same way as you can do it with RxJS, build a chain of computations, of transformations, and whenever you subscribe to it, they get active. Pretty cool thing, also pretty nice to implement performant features. They say you can use them immutable or mutable, they don't care. This is very nice because this is also true for RxJS. They say they give you this flexible effect scheduling, they can improve in a clever way of using weak maps, the explicit subscription handling. What is that? So for example, in RxJS you say .subscribe and you need to say .unsubscribe. This is basically a way how they should, or signals should, improve this explicit management and maybe avoid it completely. And they also promise us a bidirectional integration story for RxJS for the reactive system that is at the moment here, and maybe can be later on a add-on lib where you can like have a very small main bundle, and then when you need more complex stuff, you can add RxJS on top. A shout out to our buddy Enea. He directly, because he's the Mr. Angular News, I would say, he directly copied from this PR, from this RC preview, some library extraction, published it on StackBlitz, and since then the internet is, I would say, wild. Brandon Roberts, a core maintainer of a very, very nice library, NGRX, also started a repository that's called Router Signals, a proof of concept. Let's see how that goes. So there is a lot of momentum, I would say, in this whole community, and therefore also Rx Angular is a part of it, I would say, because a lot of concepts that I want to introduce today, like fine-grained reactivity and that stuff, is already implemented in Rx Angular, and I want to lift signals also on that level. And today I show you some of the templates, directives, and other things that you would need in the future to get a zone-less application. And I show it with existing features, so pretty cutting-edge experiment, I would say. First, I want to talk about the magic of signals. I'm not sure if there are many people in the audience that understand what signals are, but I built a small demo application that I can show you why some people believe they are somehow magic. And I finished the talk and the examples today, so please be kind if you see me doing some weird shit and it is not working. Like that any year. Okay, this is how I start. So, we have a user interface, and the user interface is completely, I would say, dry. We have two click bindings. This is stuff that I can delete because it was never here. We have click bindings, and we have this variable that shows us my count. And if I look at the screen, we see initial number is 0, there is a update button, and there is a reset button. And the goal is to use signals to update this button. And I will do that by using Angular's preview version for the RFC. And this is the API, so I just write signals as in pretty much any other signal implementation out there would be the same. And then I can basically use this signal here, and the signal has two options, a setter and a getter. So I can set my number to, for example, 0, if I zoom in here. I can set my number to 0 if I click the reset button, and I can increment the number if I click the update button by getting my value outside of the signal and then adding 1 to it and setting that value again. So it's a very easy to understand getter setter imperative programming, I would call it. In our view, I will directly put the getter, I will call my getter, so every time when my change detection runs, I will get an update, and we can see if that works, because that's basically it. Using a set or calling it to getting the value out of that signal that was initially 0. I recompile the application, and if I click the button, we see the number increases, and I can also reset that number to 0. And this is not really magic, I would say, because this is any getter setter object could have a get method in the template, and my change detection runs. As you see here, these numbers, this is the number of times how often the template is evaluated, here too. So if change detection runs, it's not a big deal because it's a getter setter thing. Let's try to see where this magic is, and I will create something that they call an effect. And an effect is one of those primitive building blocks that you can use to listen, to subscribe to changes of signals. How can you subscribe to changes of signals? We just instantiate or like call this effect, and then you have a function here that you call, and this is how you set up a signal. And in that signal, I can, for example, say console log. And here I can say discount, give me the value. So every time when I would change count, I would have a call here. And I will show you in steps why this is magic, or how we can understand that magic. First of all, I want to disable or unpatch my buttons. This is done with some RX Angular directives, and I do that to simulate a fully zoneless application. So in a zoneless application, a button click binding would not trigger change detection. In this application, I can do that fine granularly by putting this on one button, and then this one button would also, as in a zoneless application, not trigger change detection. The rest of the application is intact. And if I do that, it should, by commenting out that stuff here, it should first of all stop working, and I can click the button and nothing works anymore. And this is the reason, because Angular's change detection is disabled, and now I'm in a zoneless application. This is like the future for what signals should be good for. This reactive primitive that helps us to tell if something changed or not in this scenario. So how can we get this change? I told you already we can subscribe to a signal. Here I call the effect, and when I execute my application the first time, it will console log me 0. So an effect, when set up, is called initially one time. And in my effect there is very little code. There is console log, okay, some window object API. Then I have count, the getter that would pull out the value, the initial value, and then I should see it in the console. Let's start that, and I will click the update button, and here we see already a 0. And this is not really magic, because we executed the first time and we have the getter inside, so the console log will also execute. But if I click the button a second and third time, we see that I again call this log function. And for me, this was a little bit of magic. I opened up some implementations of Preact, of solid.js and so on. And I tried to understand where is the registration happening, because there is no specific thing that tells my function that this is a signal, and when this piece of the code changes, I want to do stuff, right? So My code could also look something like this. I have a variable, I assigned it, and then I say v times 2 or something else. I can like really have any code here, and this code will execute when my counter will have a set call. And that was really magic for me, because I was like, okay, I know Angular is not using some compiler patching, as Svelte, for example, is doing that. And I try to read that up, that magic, and it is my first try to explain how this stuff works. And I'm pretty far in, so let's speed up a little bit. So how is this signal registration to my effect working? I will first start with signals, and then I will show how the effect works. A signal is a setter-getter object, and if I create a signal and I call this function here, I receive something that is, if I call this create signal, I receive something that is a signal. And this signal is basically a thing that holds a container that is called observers. So this container holds all the observer of this value. And if I set a value on my signal, this observer box got pink here because I notify all my observers always when I get changed. So the set method calls notify to some people that are registered, some things that are registered in this observer array, in this observer registry. This is a signal. And when I set a signal again, or when I set a signal at all, here I go to something that is, I call it the active context. And this is a store on the window object, so everybody has access to this active context, and when I call get on my on my signal, I basically pull in the active context, and at the moment this box at the top is empty, so there is no active context present. I pull in nothing to my observers, so the observers are also empty, and I notify an empty list of observers. Not a lot of magic. But we now know that whenever I set a signal, I also notify my observers, the observers of that signal. So what is an effect? You have a signal, and whenever the signal gets changed, whenever the set method on a signal is called, the effect gets notified. And when the effect gets notified, it executes. But how does the effect know that the signal changes, or how does the signal has the effect function as its observer? I tried to show that a little bit here with these crappy boxes and this not so nice visualization, but I do my best, and it will get polished over time. So here I call this effect function, and inside of the effect function I have this lambda. And when I set up my effect, this lambda function is called for the first time. It sets itself as I am the active context at the moment, and then it executes whatever is in the lambda, for example, a getter to my signal number. So as I call get of the signal, we know from before, whenever I call get on the signal, I go to the active context, this one single storage, this global storage where the active context sits, and at the moment we know the effect that I execute the first time is the current context. So the signal that is pulled gets now to the active context, takes the thing that is in the active context and registers it inside of its observers. And that is the whole trick. If I call set on this signal again, I change the value and I notify my observers. My observers in this case is not an empty list, but the effect from before that got initialized and executed the first time. So I call notify on that effect, and the effect executes again. And what happens when the effect executes again? All the notification, context registration limbo happens again. I call get on that value, I console log it. While I'm doing this, I register it as from the active context, pull it in my observers, and done. After that execution of the second time of the effect is done, I still have my dependent in this signal. This is my current try, I would say, to explain how it works. It is Polish, it could be Polish, but I guess it is a good first understanding how this connection between a lambda function, a side effect for lambda function, is connected to a effect and a signal in it. And with this, I can basically also think that I can have an effect functions with two calls, like a number signal and a bool signal, and whenever one of those is called, because they both have now the effect registered, my effect will be executed. So I can have this one effect, multiple signals set up, and I can of course have the opposite. I can have one signal and multiple effects, and the same principle would work again. And this is my first try of explaining how this magic registration works. And that's pretty cool. Now let's go one step further. And I will introduce another line of code. I will introduce something that is called at the moment in this preview RFC a computed, and the computed is basically a composition of multiple signals, some calculation that returns a value, and it will get recalculated, recomputed whenever one of those signals inside changes, like a combined latest with RxJS. And I can call it like this. I have my lambda function, and my lambda function gets the value of count and then multiplies it by 2. And here is my new signal, where I can call get on it. So I can put that here, and instead of count, I call double, and I would log, this value times 2. So how does a computed work? I'm happy this is not my fault. I turned it off before. You saw it. So, this here from a computed is basically an effect that returns a value. And this effect that returns a value is called computed, which is basically a signal that you cannot set. A signal that is set by some content of this lambda function. I create two different types of signals. I put that in this lambda function, same as with my effect. I have no active context here because executing this from top to bottom the first time. And after that, nothing happens. So I can create the computed, and it is not, no execution happens, nothing. And this is really good and also equal to RxJS. I can compose a chain of operators, and without subscribing to the chain of operators, nothing happens. So I can create a couple of different computers, and as long as I don't call them, as long as I don't get the value of those computers, nothing will happen, like here. In the next line, I call console.log, give me the value of this computed 1. And I will take my number, and if my Bush value is true, I will multiply it with -1, and if it's false, I will multiply it with 1. So I will like flip this thing. When I call computed the first time, the computed itself, same as the effect of registered or puts a reference to it in this global state, in this global store of the active context, and says, I'm executing at the moment. This computation here is executing at the moment. And then I call my computation, and inside of my computation there is a number signal and a bool signal. So I say, give me the value of the number signal, and when I do that, while getting the value from that signal, I register the computation on myself, on the number signal. And then the bool signal executes, and it also registered the computation on the bool signal, and then we return the value. The connection is set up, and in any other situation, when somebody calls set on the number or the bool signal, I will recomputate, I will rerun, re-execute that function because I have it registered in my observers, in my observer list. And that is the whole magic of effects or effects plus, like computations. Effects that can run, can return a value that you can get the value out of it. Those, at the moment, in the RFC preview are the reactive primitives that we experimented, or that the RFC is experimenting, and the whole theory. So, if I go back, one thing that we maybe noticed is now I have the double. Okay, yeah, this is the computer that runs. I have now not 1, 2, 3, but 2, 4, 6. So I derive my value, and whenever I change count, the computed increases by 2. But my screen is not working because we are in a zoneless application. And if I would turn on zone, the whole reactivity is meaningless because we are back to this set-get system that gets pulled by the templates, like zone.js driven change detection. So let's try to implement our own change detection. And what I can do is I can quickly copy in a render function. So I created a function that basically takes the change detector ref and instantiates it. And then, after I promised, this is at the moment more bug fix, it creates an effect, and in this effect it consumes a signal, the signal that I hand over in this render function, and now this render function is called whenever the signal changes, right? Because I have an effect, and in the effect I call get. Registration set up. So, the first and every other time I will call detect changes on my change detector ref, and I will update the components template. I could now go here in my minimum setup and register this here instead of that. I call render effect, and I pass in my double, and with this setup I should see that my screen, that my view updates, and luckily it works. I didn't test it, and luckily it works. My screen updates, and basically now we see a first step how we can run change detection if a signal changes. I pass in a signal, I register an effect, and in my effect I call detect changes on my reference. And this is a very well-known pattern, because this pattern is present in other building blocks of Angular already. So let's start with how can we use that in Angular, because we for sure will not call this render effect function in every component, or most probably not, this is my assumption. And I will show you two building blocks that we already have in RX Angular that at the moment enables the same feature set but with RxJS. And one of those building blocks we have there is the push pipe, and another one is the RxLet directive. And I want to show how we can create those reactive primitives at the moment with signals. So Angular is a component tree. At the top, this blue square is my application reference, and the push pipe is our first reactive primitive to understand, to trigger change detection. What is a pipe in general? We already know the async pipe. The async pipe, registered in a template, can take an observable, and when the observable shoots a value to that async pipe, I call, or the async pipe calls mark dirty under the hood, marks a couple of components as dirty, and in the second tick, zone.js kicks in and re-renders not the whole application, but at least this dirty path, no matter if you have on push everywhere or not. At least those three things are re-evaluated by the tick method that renders from top to bottom. And this here is the async pipe cycle, I would call it. We could directly say, let's take that mechanism and let's just, instead of subscribing to this observable, wrapping the signal with an effect and just getting the value inside. But in our example, we also try to go a little bit more in the performance area, and we said, okay, why should we execute change detection again through the whole component tree? We can also call detect changes. You can only execute change detection on this single component and no dirty marking or nothing is in place. This is the first demo that I want to show you. So, without having this clumsy function that calls detect changes on our change detector ref all the time when the signal here updates, we can introduce another concept. And this concept is called the async, the push pipe. So we have a writing that is like this, a usage, I have it registered already. And I will first show if it works with both buttons unpatched, and then I can jump into the implementation. I will delete the render effect at the moment, so there is no calling detect changes from this rudimentary function. Empty component, I start my application again. The buttons are still unpatched, and if I click now a button, the number updates. Why does the number update? Because I have the count signal in my template and I use the push pipe there. The push pipe takes the count signal, wraps it in an effect, and will trigger change detection whenever the value changes. That's a first building block that we have at the moment ready in RxJS. The second building block, and I really have to rush now, that I want to present to you is a little bit more efficient and also a very old concept. The ng-led, the LED directive, the Rx-led, all those implementations referred as LED something are basically an idea from 2015, from Rob Warnard, and I refreshed that idea already when we released Rx Angular 3 years ago, and finally I can introduce the same idea with Angular's original roadmap and signals. So Rx-led is basically a very interesting and nice way of triggering change detection. First, let me give the theory and then I'll show you how to use it. My structure and directive also exists in a component tree, and in this component tree I want to introduce to you now a new visual system. I don't only have a green box, I also have a green dashed box and a green dotted box. Everything green, everything template, but smaller sub building blocks. And if I look at this tree and I zoom in into one single component, I see something like this. I have 3 different things here. Interestingly, I get an input binding value change, and this value is rendered as value binding in my template and is also forwarded, or some other value is forwarded, to 2 structural directives, an ng-for and an ng-if. Thanks for the comment. If I zoom in more, oops, let me start the presentation with the best for all of us, right? If I zoom in more, I have, as my structure directive, a view container reference. We don't really need to understand what it is. And inside of that container reference, I have some embedded views. Also not really interesting. The interesting part is that embedded views are the smallest building block in Angular's template. So this is the smallest recognizable unit in Angular's templates. And when we digged into the source code, this was already back then, when we did the Rx Angular version with observables, we realized that there is a very interesting attribute on an embedded view, and this is the embedded view has also a method that is called detect changes. So instead of executing change detection on the whole component, this green fat border here, we are able, with a little bit of more tricks, to exactly execute only this single value that's changed. So nearly on the binding level in the template. And I want to demonstrate to you now how we can use that and especially how we can implement that. And then the whole thing is done, I would say. I jump into my example, and what I will do here is I will add another directive that is called rx let. And in this case, I didn't use the original Rx Angular implementation. I just made a first proof of concept how the next release will look like and named it the same way. But you can have basically whatever. I could also have it named just let. So with this naming, I can pass the signal itself. I don't call get, same as with the other implementation with observables. I pass the observable itself inside. And then I can create a variable. I will make a shortcut here, C, and with that variable, I can now work inside of this scoped embedded view. And my scoped embedded view is now this little box here. And not my whole component anymore. So any other piece in my component, especially when your components are bigger, are not impacted, and I can demonstrate you the outcome in the demo. I need to implement it first, import it first. Rx let directive. That looks good. Okay, I can use it. So, initial rendering works, that's good. I click the button and my update also works, but one interesting side effect. Neither my whole application changes, so gets evaluated, nor this number here gets called a single time. So this is a very nice improvement. I can quickly show you the implementation and then we do a recap. So in this structural directive, if I zoom in, this is like typing. Any structural directive needs typing, so this is not magic. Also not magic, typing stuff. Here, again, as with the async pipe, I have my last signal or my last observable, depending on what we're dealing here. We deal here with signals. I have my subscription. The typed name of a subscription to an effect is called an uppercase effect. This uppercase effect has then this onDestroy method, and I need a place where I store my embedded view, my view container that creates the embedded view, and I also need a template reference where I can like build a small snippet and move it in. So this down here, update view, is what you will always need to do if you have a structural directive. This is not the magic. This is basically just adding a value to implicit and the name of my structural directive. ngIf, ngFor, any other structural directive will do the same. So let's ignore this logic, and also let's ignore the onDestroy logic, because on onDestroy we just call destroy on the effect. Let's go inside of our input binding. And whenever we receive a new value from the input binding, which is the same, I just return, nothing happens. So same signals comes in, no change, nothing. I return. If there is a new signal or the first signal, I will save that as my last signal. I will, if present, unsubscribe from everything previously actively running, and then I will call again my side effect. I have a little bit of code here that is too much. It's maybe too much for today. And then I call the getter of my signal. This is the registration. Whenever this signal will now get set to another value, I will execute, and then I have updated my view with the value and call detect changes on the embedded view. And that is it. This is the implementation, and this is the reason why we don't see changes here on the numbers. I also have a little bit more complex implementations where we have more meaningful usage of computed, and we also have, if we go to the more complex version, HTTP requests and counters. Like we could start a counter, but it would like not fit in the scope of today's talk. In this talk, I just wanted to give a little bit of an introduction. I just scratched what we can do with the RFC preview. We will get the real RFC in the future, in the very near future, and then we will see if it holds, if it is a good planning behind it, or if we can tweak it a little bit, and then they will release it. So recap, what did we do today? We had a very early but very interesting first look into what our Angular signals might look like in the future with the preview RC that is currently online on GitHub. The links are in my slides. I introduced you to the building blocks, the signal, the effect, the computed. I showed you how you can use signals within Angular, like running change detection signals. This, I believe, will be the important or interesting part in the future. And I showed you two of the directives that are at the moment running in Rx Angular as a first proof of concept, how they can look like with signals. It's nearly identical as with observables. The difference, just to recap, is that we have on the push pipe, we have a change detection on the component level. With the let directive, we have it on the binding level. This is a really nice benefit and a really interesting difference, and that's basically it. It will land in future Rx Angular versions. We are extremely interested in that stuff, also to build a nice bridge to integrate that with the current system of Rx Angular, or ship some standalone, very lightweight helpers where you can deal with signals. If you like the talks, follow our repository. Maybe in best case you should start it right away, because this is the place where the future happens. And that's it. My name is Michael. If you have any questions, feel free to ask me. If you need the resources, the repository is linked here. Just click the link or type it in. It's very easy. It's on Bitly and it's called Signal Experiments Repo. That's it. Thanks for your time and